final speaker is Jean-Claude Gerardy, and he is a structural engineer with Arcelor Mittal, and he is currently their technical advisor for all the Eastern European countries. So please welcome Jean-Claude.
So good afternoon or good evening almost for everybody. I'm happy to be here. I'm also happy to see that all the planes are leaving Dubai during the night. So being the last one, I'm happy to see so many people. So I will talk today about the new developments that have been done in Europe concerning fire safety with sustainable steel buildings through national fire safety concept. Just a few words about hot roll section. Having been here 4 days in Dubai, I've seen so much concrete in my life. I've never seen so much concrete in my life. So sustainability of hot roll sections is really very good. So today, steel, any ton of steel today is coming more than 50% out of scrap, so it's recycled material, and the steel production of beams, hot roll sections in the world, it's produced almost exclusively from scrap basis, so it's indefinitely recyclable. So fire safety, I will not explain because you have seen it since this afternoon. You have different, for the fire safety, the goal is to reduce the risk of both life and property losses with different active system, passive system, and I will focus mainly on the passive system where you have the structural fire resistance, which is defined in the codes. So in the codes, you have nominal fires, which is the well-known ISO curves, or you can use today also natural fires that have been introduced in the Eurocodes. And they are also based on scenarios that you define with the fire brigades. So the well-known curve is the ISO curve, and you can see that on the horizontal axis, so is the time, vertical axis is the temperature. So this curve is really a theoretical one. It means that, for example, if I put fire on this table here, after 4 minutes, the column here in the back will be at 400 degrees. So could you imagine that? It's completely silly. So this is absolutely theoretical things. There is only one curve that you can use. It's not even taking into account the type of building. So if it was a swimming pool, you use the same curve. If it was a fireworks factory, we use exactly the same curve. So it's completely silly. So in the Eurocodes, you have different methods to make the design of your structure. The simple one is based on this ISO curve. So you are designing one single element. You can design one single column, one beam, and you use this this ISO curve to simulate the fire on it. So you know that when the temperature is increasing, the steel grade or the steel yield point is decreasing, and at 400 degrees centigrade, the yield point is automatically decreasing. The yield modulus is already decreasing when you reach 100 degrees. In the Eurocodes, when you have a fire, if we have a fire in this compartment here, you don't need to take all the life loads that you have on top of it. So you can reduce the life loads from the factor 0.7 to 0.3. That means you have a certain reserve compared to the cold design. When you design this column under cold condition, so you still have a certain reserve to take the fire for a certain amount of time. So either if you are a lazy structural engineer, you say, I'm doing my design, and then, okay, I need 2 hours, we do a protection for 2 hours, so you just protect this column for 2 hours. If you are a little bit smarter, just by doing small calculation, you use the simplified method given in the Eurocodes, and you can show, I will not explain in details this graph, but you can show what kind of thickness of protection will be needed to sustain the fire for a certain period of time based on this reduction of life loads that you have in your structure. So unfortunately, bare steel can just sustain a fire of 30 minutes. If you want more than 30 minutes, if you have a fire resistance more than 30 minutes, then you need to protect the steel. So all this methodology is accessible on a website. It's a website from a BCI in United Kingdom. So if you want to learn how to apply this simplified method in Europe, you can go on this website. So the system is based on the massivity of the steel and the protection. So by using this method, you can find directly the quantity of material that you have to use to protect the steel. One solution is to use well-known board fire protection. Another one, which is the cheapest one and the most common that you can find in the United States, is to use a spray fire protection. And a third one, if you want to see the steel, you can use intumescent paints. So, but if you use the simplified method, you have not really an aesthetic solution. You don't have a competitive solution. This is why the concrete building, as they always say, or concrete is safer than steel structure for fire, but there is a possibility to do some fire engineering to show that a steel structure could resist more. So it's not really sustainable when you do a pure simple fire protection like we are doing. We are learning to do design against the wind loads, the seismic loads. We should also start learning how to do a design against fire. On top of that, fire protection, if you just apply a simple fire protection, it will cost you 20 to 40% more. So in the Eurocodes 1, 3, and 4, it has been developed in the last 10 years, a new method to do real fire safety engineering, taking into account the global structural behavior and taking into account the development of the fire within a compartment. So in red, you see here the ISO curve, standard curves, which is not representative of a real fire. And in the Eurocodes now, it's possible to find the blue curve, which is really function of different parameters, like the fire loads, the type of usage that you have in the building, the type of ventilation, if you have ventilation, if you have fighting measures, using sprinkler, no sprinkler, and so on. So you can really define this curve based on the different parameters that you have in the structure, which is more realistic. There is also another factor that can be used here. Sorry, I asked to have no sound, and I have sound, so sorry. During a fire, there is always different zones. So if there is a fire here, the temperature on the roof will be extremely high quickly, but here on the bottom, at the low level, it will stay cold for a certain time. So here you can see on the simulation, here you have hot temperature on the top of the room, and on the bottom of the room you can still have a low temperature. This parameter can also be taken into account when you are designing this curve, finding this curve temperature versus time for the calculation. So from 1994 to 2006, we have performed everywhere in Europe many researches to define this fire engineering approach. All of them have been based on natural fire. Methods today are all available. We define also and we validated scenarios where we say if you have an office building or you have an hotel where the fire should be simulated, and then you use a finite element program to simulate the fire based on the curve, the temperature curve that you have obtained. The biggest problem is when you try to change regulations or standards, it's taking time, so it took us 10 years to change all this regulation. And now we are really training engineers and explaining all the engineers how to use these methods that have been accepted in the Eurocodes. So tools are available. There is one tool to find this curve, which is a software called Ozone that you can find on our website completely free of charge. So you can directly obtain by giving all the parameters that you have in the building that you can find the temperature curves. Trainings have been organized all over Europe by many institutes, by many universities, and I will talk a little bit about that later on. And there is also a club of engineers which are specialists on the fire engineering using a natural fire. So without going into details, here you can see instead of having only one ISO curves, depending on the different elements or different parameters, you can obtain different curves. Everything is based on existing past fire in different buildings. So you have different parameters that are based on probabilities of having a fire, a probability of having the time for the fire brigades to come on the site, or if you have problems with the sprinkler. So all these parameters are taken into account. We'll skip this one. Also, the compartment, so when you do the design, if you have one compartment, the system allows you to take into account the material that are used in the compartment and also the openings, if you have openings in the compartment. So we had a huge program in Europe with all universities involved, and it's called DFISEC, it's Dissemination of Fire Safety Engineering Knowledge. So in 2006, we had a different symposium all over Europe, and this year we are going to extend it to Eastern Europe. So you can find all this information about fire engineering, and a lot of examples can be found on this website. Also on access steel, if you have to design a project in Europe, you can find a strategy depending on the type of buildings that you are designing. They are giving you examples of design or what kind of fire protection to use depending on the occupancy of the building. So like I said, we have what we call a Secure with Steel club members. Today we are about 25 engineers, and they are really well known all over Europe by the fire brigades, and they can do real simulation using fire element analysis. And next week, or I think it's next week, yes, we have from March 12 to 14 there will be a new training for all these engineers, so, and it's open to everyone. We will have this year, I think, even engineers from Australia who wants to learn this technique. So if you want to participate, you can contact me, and I will put you in touch with the people. So in 3 days, you will learn how to do this fire analysis according to Eurocode 1 and 3 and 4. Now let's stop the technical part and let's see some examples of application. The first one, it's of course it's our building, Arcelor Mittal. So we wanted to have a building where we can see the steel. So we designed this project. It's a 7th-floor office building designed with this natural fire concept. So we are using a slim floor concept. And we demonstrated by finite element program that just by having the continuity here in the slab, it was possible to avoid the fire protection on the lower flange of the beams. So we made different simulation. We have 2 atriums, 2 offices with 2 bracing systems, and this is the core design. When we are doing the core design, we design this beam being hinged with the column. So, and we are using, of course, the bracing system for the wind loads. And during the fire, we say, because we are not protecting this bracing, so we say the bracing is not existing anymore, but we are using both the semi-rigidity in the join combined with the continuity of the slab to just demonstrate that we don't need any fire protection in this case. So the fire brigade say, yes, this is nice, but we would like to see some examples where you have a fire in one compartment here, but when you have problems with the sprinkler system. If the sprinkler system is not working, what will happen? So we made also another calculation with different temperature curves here. And then it was also possible to show with the semi-rigidity of the joint, in this case, that it was possible to use the structure without any protection. So you can see here the atrium with the bracing system not protected. Another building here, they use exactly the same concept, so just by having this additional rebar in the slab, there was no need to protect the lower flange of the beam, and you can see it was for a 2 hours fire. Another building here, it's the Medical Center in Luxembourg. They use also a composite design and slim floor with natural fire design, and by using that, they were able to demonstrate that the columns were not needed to be fireproofed. By doing these simple calculations, they were able to save 100,000 euro. Another building here in Switzerland, it's a school, existing school, built in 1970. So they wanted to add one floor and they wanted to renovate the school to be able to sustain a fire of 60 minutes and also by installing a sprinkler. So here the solution is this one. So they have a tubular column filled up with concrete, and for the beams, they were using castellated beams in both directions, and doing this fire element analysis, it was possible also to show that no protection were needed. In this case, we even also perform a test in furnace. So you can see here the simulation of the fire, and here you can see the simulation or the real test in the furnace. This hall, it's an indoor football arena in Finland. Same thing, they use natural fire. And here it was possible to demonstrate that only when you have one stand here, like an exhibition stand, which has only 14 megawatt of fire load, that only 25% of the structure needed to be fire protected. So 75% of the steel was kept unprotected. Another bank here in Luxembourg, so we have many banks in Luxembourg, as you know. So it's an office building, 4 floors above the ground, and underground 3 floors. They used here, this is very well known in Germany, they really like to use this system. They use composite columns by pouring concrete between the flanges. So in this case, the beams were unprotected for the office, and the columns, they use encase concrete between the flanges of the column. For the underground car parks, they use a composite and beams and columns using the same system. Just one very interesting thing here, we don't see it anymore, but by using an extended end plate connection here, and by having here this plate a little bit entering into the concrete, they were able to demonstrate that they have enough stiffness inside this connection to show that the beam didn't need to be protected. Okay. So if you want to design also this type of sections, we have softwares available on our website. One example, the same thing here, it's a shopping center in Luxembourg. Just by increasing here, they use also castellated beams, just by increasing the thickness here of the weld, And just by adding these two plates back here to close the holes, so they were able to sustain a certain moment here, and with that it was not needed to be fire protected. So I think I will finish here, otherwise I will take more than 2 minutes then. So thank you very much for your attention.